Hi class! Today we're going to do applications of quadratic functions, which I know is your favorite thing because we get to do word problems. So let's jump in with some strategies first. Let me go to the next slide. All right, so our strategies. The first thing you're going to do is to read carefully. Please read the entire problem before you start doing any work because you want to know the whole full scope of it and then decide what's being asked for. Then once you know what they're asking for, you can use the information that's given to you to write the equation, a function with one variable. So f of x equals x, blah, 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 blah. Now we are working with quadratics, so they are going to be quadratics, and so we want to write it in the form of ax squared plus bx plus c. That's our general form, or I like to call it the ABC form, and that's going to give us some familiarity with what we're doing with this. Then we're going to use those calculations to find the quantity that's being asked for. So you'll just do the calculations. Certain things will ask for what x is with the x-intercept, maybe the y-intercept, maybe the maximum, maybe the minimum, things like that. And then once you know, you're going to look back and say what was being asked for, and then answer the question and give it to me in words. Don't just say, hey, 4. 4 what? 4 inches? The length of the side is 4 inches. You know, the person gets 4 cookies. Give it to me in words. So let's jump into some examples and see how it's done. All right, so we're going to look at an example. The example reads, an archer's arrow follows a parabolic path. The height of the arrow, f of x, in feet can be modeled by f of x equals negative 0.005 x squared plus 2x plus 5, where x is the arrow's horizontal distance in feet. We want to know what the maximum height of the arrow and how far from its release does that occur. So we have a drawing. Let's give a quick little drawing here. So if we were to graph this, it's going to start, this is our height going up and down, and this is the distance, and it's going to be something like that. So this is our distance. This is the height. And we want to know the maximum height, so we're looking for that vertex at the top there. And how far its release was, so we're looking for both the x, the how far, and the height, which is the y. And that's the vertex, so we're going to use that negative b over 2a. That will be our x, so that's how far it is. And then we'll plug that number into the formula. So we're going to take negative 2, and we'll put that over 2 times a is negative 0.005. And that's going to give us 200. So, and then we put that into f of 200, and that equals negative 0.005, and we'll have 200 squared plus 2 times 200 plus 5, and that's going to give us 205. So the answer to this question is that the max height is 205 feet at a distance of 200 feet. The next thing in this one, we're going to find the horizontal distance that the arrow travels before it hits the ground. So that's making our f of x is equal to 0. So we can use the quadratic formula to do that. We'll do negative b plus or minus the square root of b squared minus 4 times a 0.005 times c, which is 5, and that's all under the square root, divided by 2 times a, which is negative 0.005. We're going to put that into the calculator. Keep in mind that we have a plus and a minus, and we're always only accept the positive answer because our distances are not going to be measured in negative terms. Answer. And so this one is, when I round it to the nearest foot, it's going to be 398 feet away from the release before it hits the ground.
We know some information, some important information about this graph, and we want to graph it. So we're going to have, it's only going to be in the x coordinate, or in the first quadrant, and this is going to be our height, and this is going to be our distance. And you really only need to have some key points on there. So I know the highest point it gets to is 205, and the furthest it goes is 400. And we do know that it's starting at 5. So we're going to make this coming up to at 200. That's our maximum, going down, and it looks like that. And that's all you really need to do for the graph.
For our next example, we're going to look at pairs that are possible whose difference is x, and their product is as small as possible, so that we can find that very minimum product. So we're going to let x equal one number, and we're going to let y equal the other number of their number. And so their difference, x minus y, is going to equal 8. Now if I do substitution, or just do some moving around here, I can do add y to each side, x equals 8 plus y, and then we're going to subtract 8 from each side. We get y is equal to x minus 8. And then we want to know the product of those two numbers is going to be x times y, and we're going to substitute that x minus 8 in for that. Now this is a quadratic. So if I distribute that, I'm going to get x squared minus 8x. And what we're looking for is the minimum. This one opens up. We want the smallest one, so we want that vertex. So we're going to do negative b over 2a. So that's negative 8 over 2 times 1. So that equals 4. And so one number is 4. And the other number is negative 4, because we put that in here. X is 4 minus 8 is negative 4, and their minimum product, when you take 4 times negative 4, is negative 16. All right, so in that last example, it states we have 120 feet of fencing to enclose a rectangular region. We want to find the dimensions of the rectangle that maximizes the enclosed area. And what is that maximum area? So we have a perimeter that's 120 feet. And we want, and that's going to be 2 lengths plus 2 widths is going to be that 120. That's how we get our perimeter. And we want the length times the width, the area, to be at its maximum. So if I take this and I solve for one of the, let's solve for W. So if I subtract 2L, I have 2W equals 120 minus 2L. Then I divide by 2. I'll have W is equal to 60 minus L. And our function then is going to be the length times the width, because that's what we want to find the maximum of. So we're going to go the length times the width, but we're going to substitute 60 minus L. So if I distribute here, I have 60L minus L squared. Now this is our A term, that's our B term, because we would write it negative L squared plus 60L. So I'm going to use negative A, which is negative 1, over 2 times B, which is, I'm sorry, I did that wrong. B is 60, right? So let's cross that off. It's negative 60 over 2 times negative 1, which gives us negative 60 over negative 2, which gives us 30. And so if the width is 30, then we want to find what the length is, or the length, I'm sorry, this is the length. So let's put it back in here, 2 times 30 plus 2 times W equals 120. So that's 60 plus 2W equals 120. So 2W is equal to 60, and W is also equal to 30. So what's the maximum area? If we multiply that together, it's 900 square feet.